Hello friends, myself Rajendra Mahajan presenting my video on matrices, point normal form of matrix. This is the revision series for matrices or matrix. First video is about the normal form of matrix. Question is find normal form of matrix A as elements are 1 2 1 2, second row 1 3 2 2, third row 2 4 3 4, and fourth row 3 7 4 6, and sub question is hence determine its rank. And therefore to find the normal form and its rank, first of all we have to convert this matrix to its canonical form. Canonical form means what? We have to convert the lower diagonal elements to 0 by applying elementary row transformation, and after getting that canonical form we have to convert upper diagonal elements to 0 by applying column transformation. Means we have to apply both row as well as column transformation. Therefore first of all I am applying row transformation. The leftmost element is here 1. Keeping that 1 as it is, we convert the remaining elements below that 1 to 0 with the help of that 1. Therefore 1 minus 1 we get 0, 2 minus 2 we get 0, and 3 minus 3 we get 0. Means the transformations are by R2 minus R1, 3 minus 2R1, and R4 minus 3R1 we get. In a single step we can perform all this calculation. Therefore first row no change. I will try to explain the steps with very simple language, though it is in English. Therefore first row no change, 1 2 1 2. Changes are in second, third, and fourth row. Therefore using this R2 minus R1 we get 1 minus this 1 0, 3 minus 2 we get 1, then 2 minus 1 we get 1, this 2 minus 2 we get 0. These are the elements of second row. Then we apply R3 minus 2R1, means first row is multiplied by 2 and subtracted from third row. Therefore this 2 minus 2 we get 0, 4 minus 2 to the 4, 4 minus 4 we get 0, 3 minus 2 into 1, 3 minus 2 we get 1, and 4 minus 2 to the 4, 4 minus 4 we get 0. Therefore this is the third row. Then fourth row is obtained by this R4 minus 3R1. Therefore 3 minus 3 times 1, 3 minus 3 we get 0, 7 minus 3 to the 6, therefore 7 minus 6 we get 1, 4 minus 3, 4 minus 3 we get again 1, and 6 minus 3 to the 6, 6 minus 6 we get 0. Therefore 0 1 1 0, these are the elements of fourth row. Then here the first step is completed. First element is converted to 1, already it is 1, and the remaining elements below it I have converted to 0. Then we check the second diagonal element. Here second diagonal element is 1, non-zero, and using that element whatever the elements below it, we convert them to 0. Already 1 is 0, this one is 0. Then we go for the this second element in the fourth row, convert it to 0 with the help of this one. Therefore 1 minus 1 we get 0, means the transformation is R4 minus R2, and therefore we have no change in the first, second, third row, only change in the fourth row. 1, 2, 1, 2, no change. Then 0, 1, 1, 0, 0, 0, 1, 0, no change. Changes are in the fourth row element by R4 minus R2, means from fourth row we have to subtract second row. Therefore 0 minus 0 we get 0, 1 minus this one we get 0, 1 minus 1 again 0, and 0 minus 0 we get 0. Therefore if we see, first diagonal element is 1, remaining elements in that column as second diagonal element is 1, remaining elements in that column are 0. Third diagonal element is 1, remaining elements below it as 0. The fourth diagonal element, in the process it becomes 0, and no element available in front of it or below it to make it non-zero, means as no element is available, we keep that 0 as it is. And whatever this form we have, where all the lower diagonal elements are 0. Here, whatever this form we have, it is called as the canonical form of that matrix. If the question is to find the rank only, then here we can stop the calculation. After getting canonical form, we can determine the rank of the matrix as a number of non-zero rows from this canonical matrix. Therefore, if you observe, first row is non-zero row, second is also non-zero row, third is also non-zero row, and fourth is a 0 row. Therefore, the rank of that matrix is 3. By writing the statement like this, rank of the matrix is 3, we can stop the calculation. But the question is not to find the rank, question is to find the normal form. Therefore, after getting canonical form, we have to convert upper diagonal elements to 0 by applying column transformation. Means using the first element 1, we convert 2, 1 and 2 to 0 by applying column transformation, and that column transformations are 2 minus 2 0 means C2 minus 2 C1, then 1 minus 1 we get 0, it is C3 minus C1, and 2 minus 2 0 means C4 minus 2 C1. First column no change, therefore that first column is 1 0 0 0. Then changes in second column, I will show this once again. 2 minus 1 times 2 means 2 times 1, 2 minus 2 we get 0, and remaining elements remains as it is, as the elements are 0 in that first column, and therefore second column becomes 0 1 0 0. 0, 1, 0, 0. C3 minus C1, 1 minus 1 we get 0, and remaining elements as it is, as these three elements are 0. 1 minus 0 we get 1, 1 minus 0 we get 1, and 0 minus 0 we get 0. Therefore, third column is 0, 1, 1, 0. 0, 1, 0, 1, 1, 0. 0, 1, 1, and 0. Then C4 minus 2C1. 2 minus 2 times 1. 2 minus 2 we get 0, and remaining elements as it is. Therefore, that fourth column becomes 0, 0, 0, 0. Then, using second diagonal element this 1, we have to convert this 1 to 0. Therefore, the transformation becomes C3 minus C2. We get first column no change, 1, 0, 0, 0. Second also no change, 0, 1, 0, 0. Third, there are changes by this C3 minus C2. Therefore, 0 minus 0, 0. This 1 minus this 1, we get 0. 1 minus this 0 as 1, and this 0 minus this 0, we get 0. Fourth column, no change, 0, 0, 0, 0. And if we observe the elements, first three diagonal elements are 1, 1 each, lower diagonal elements are 0, fourth one is 0, and it is not possible for us to make it non-zero, and the upper diagonal element we have converted to 0. Then we stop the calculation here and try to separate the identity matrix from this matrix. Therefore, 1, 0, 0, 0, 1, 0, 0, 0, 1 is the identity matrix. Therefore, we can draw a line like this, dotted line, and vertical line, again dotted line. Therefore, this is the normal form of that matrix, and we have to write it in symbolic form. Therefore, the symbolic form is identity matrix of order 3. Therefore, we call this as I3. In front of it, a column matrix containing all elements 0, therefore 0 matrix. Below it, another row matrix, 0 matrix, and the fourth one is a 0 element, therefore 0. Therefore, this is the symbolic form of that normal form, I3, 0, or we can write down Z also. Below 0 and another 0 matrix. Therefore, this is the normal form, and using this normal form we can find the rank as the order of that identity matrix. What is the order of that identity matrix here? It is 3. Therefore, using that order we can write down the rank of the matrix, and we can easily check with the rank whatever I have just explained after getting the canonical form. Yes, what is the rank we are getting here? We are getting rank as 3. Therefore, we can cross check it whether that rank is equal to this rank or not. If we get the same rank, then whatever the calculation you have performed is the correct one. For a very simple technique, once again I will repeat the steps. In the first part, we have to convert lower diagonal elements to 0 by applying elementary row transformation, and all diagonal elements are non-zero. Here 1 1 1 1 means non-zero element, and the upper diagonal elements we convert to 0 by applying column transformation. And after getting this form, we separate the identity matrix by making a line like this, horizontal line as well as vertical line, and then write down the symbolic form of that normal form. For this particular example, it is I3 0 0 0, and hence rank we get as 3. In my next video, second video in this revision part, I will discuss how to solve linear simultaneous equation of non-homogeneous type. Please like my video, share it, as well as subscribe to my channel, and to receive the notification for my such type of new videos, please press the bell icon. Thank you. Thanks for watching.